This is page 220, number 19. Okay, so we have a person flying a kite, and they hold the string 5 feet above ground level. So we're already kind of seeing some sort of right triangle where we've got the kite up here, and the person is holding the kite about 5 feet above ground level. The string is paid out at a rate of 2 feet per second. So that's this distance here. I'm going to call this z. So we know that dz dt is 2 feet per second. And the kite is moving perfectly horizontally in this direction and is remaining constant at an altitude of 105 feet, which means that this dimension here must be just plain old 100 feet. So our job is to find the rate at which the kite is moving, when 125 feet of string has been paid out. So that would be the rate of change of this segment here. That's the rate at which the kite is moving. So let's call this x, and we are looking for dx dt. We need a relationship between x and z. We are looking at a right triangle, so I'm thinking Pythagorean theorem. So x squared plus, that's just going to be 100 squared, because that's always 100 feet, equals z squared. Now, we take the derivative to find out how their rates are related, so we get 2x dx dt. The derivative of 100 squared is going to be 0. We can cancel out these 2's, which means that x dx dt is equal to z dz dt. And let's substitute some values. We are looking for dx dt. We know that z is 125 feet. We know dz dt is 2 feet per second. But we need x. We don't know what that is. But we are here looking at one side of a right triangle as 100 feet. Z at this moment is 125 feet. So we have a 3, 4, 5 right triangle happening. So this would be 75, 100, 125. If you're not sure about that, you can always just use the Pythagorean theorem. You'll get the same thing. So x should be 75 feet. So dx dt is equal to 250 over 75, which reduces to 10/3 feet per second. Again, notice that the units line up, that x is measured in feet and time is measured in seconds.